Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on CO2 sequestration modeling. It's in saline aquifer and we will perform it using CMG software. And in previous video, we have constructed a model with structural hysteresis and also solubility trapping. We already did the modification or the modeling, the fluid modeling using wind probe. And then we also have run the simulation on the gem. So in this video, we will visualize the results. So I already opened my results. And of course, we will take this .sr3. Click on open. There you go. So let's go to this reservoir model. And you can see the 3D view as usual, but let's go first to 2D view like this. Okay, and then go to display. And what do we want to look at? Maybe first we can go to, as usual, gas saturation. Okay, play. All right. Now you see the red area, now it's very short. And we still have the yellow area, showing that the CO2 is trapped by hysteresis trapping and also added by the solubility trapping. Okay, it's very, very interesting. And because of the solubility trapping now we have even stronger trapping, which will restrict the movement of CO2, which will restrict the propagation of the CO2. That's why you have CO2 that is shorter on the top of the aquifer, on the top of the, the storage. So this is how the gas saturation looks like. And of course, we can also check as usual again. Yeah, right? It's very different from structural trapping. It's very different from structural plus hysteresis trapping only. Go back and play. Right? Short, and you see more and more CO2 trapped from the bottom up to the top. Okay, it's very, very interesting. And we also now is very interested to look at the water mole fraction of CO2. So this is the CO2 dissolved in the water. And we want to know the mole fraction of the CO2 within the water. So it's wise to go back and let's go to water mole fraction, starting from red color. All right, you can see there, you see now, interesting. Okay, we can also adjust color scale editor, and let's say I want to make it maximum to be like this. Okay. Wow. Right. So now mole fraction, more and more CO2 dissolve in the water, in the brine, and you see the shape, the profile is like this, right? So at the bottom it is sort of covers more area than what we have on the top. You see, because now CO2 being dissolved in the water becomes actually heavier than water without dissolved CO2. Okay, so if the CO2 is dissolved by or if it is dissolved into the brine, the brine will be heavier, so it will of course go down because of gravity. Okay, we can also, again, so we can also check the same thing, water mass density. You see, right? But maybe we can adjust the scale. Hopefully we can see even more clear difference. And what about like this? You see there. Okay, and also like this. Now, all right. The density, the blue density is heavier, is higher than the red density. Okay, so now water with dissolved CO2 will be heavier than all other brine without CO2. So now water containing CO2 will sink to the bottom of the aquifer because of gravity, which is good. So because now our CO2, which is greenhouse gas, now the CO2 is trapped, being dissolved in the water, and it sinks. It goes to the bottom of the aquifer, making the escape of CO2 into the atmosphere much more difficult. Okay, so being accumulated at the bottom will increase the safety, will increase the permanence of the CO2 being trapped or contained in the storage. So that's the idea. It's very, very, very interesting. And we are also interested in comparing, this result with structural trapping only and with structural plus hysteresis trapping.